All right, we have ourselves a rational function and we are being asked to answer a bunch of questions about it. Now let's take a look at what we have first. We see in the denominator multiplicity. This is what's called a perfect square trinomial, and we have multiplicity. When you're dealing with multiplicity and you're expecting things to be the same, that kind of changes domain, not so much domain, but whole, zeros, and vertical asymptote behavior. So let's do this first. Let's ignore the multiplicity part. We'll get to that in a second. Let's deal with the domain. The domain is what number am I not allowed to plug in? Any number or numbers that makes the denominator equal to 0, I'm not allowed to plug in. For example, 2 would make the bottom equal to 0. 2 is the only number that would make the bottom equal to 0, which means 2 is not allowed in my domain. So the way we write that out is we say negative infinity to 2, not include the 2, that's what the parentheses means, union, and then 2 on to infinity. Now I have to take into account this multiplicity thing. What I need to do is I need to factor the top part, the numerator. So I need to come up with two numbers that add up to 4 and multiply out to negative 12. And I think x plus 6 and x minus 2 should do it. Now I still have x minus 2 squared on the bottom. I'm going to write this out both ways. Not that it's necessary, but it might help me understand things a little bit better. X plus 6, x minus 2, x minus 2, x minus 2. Now, whenever you have multiplicity and you have repetition going on in the numerator and the denominator, this is what you're going to take into account. Okay, my magic number here is 2, my magic number here is 2, and my magic number here is negative 6. Whenever your multiplicity, and if you have repetition, whenever your multiplicity on the bottom in the denominator is an odd number more than whatever repeated factors you see up here, you are going to have a vertical asymptote. Okay, so basically the behavior of this happens. Now I know that's a whole, but this 2 is also the same exact number. So which is it? Is it a whole or is it a vertical asymptote? Well, since this goes away, the graph now behaves like this. Either way, you're not allowed to plug in 2. But now, since this part goes away, you are left with a vertical asymptote, and the whole behavior is now gone. So 2 is a vertical asymptote and not a whole. That leaves me with a negative 6 up here that I am allowed to plug in, and that negative 6 becomes a 0. So if you're wondering, all right, well then what's my whole? There is none. And again, that's because you have more factors on the bottom than you have up here that are the same thing. So that takes me to my limit notation and horizontal asymptote and behavior and all that stuff, which is basically the same thing. Except for this part, limit notation of the vertical asymptote. Now, since the graph behaves like this, my picture is either going to look like this guy or like this guy, because now it behaves like this. And if I wonder, all right, well, which one is it going to look like? It's going to look like U, this one right here. And the reason why it looks like that right there is because both of my leading terms are positive. So it's going to take on this behavior. If I wanted to go into more detail, I can make myself a sign chart, but I'm not going to do that. So what it's asking me here is the limit notation of my vertical asymptote, which happens at 2, is going to look like this. As I approach 2 from the left side, that's what that little minus sign means, of what is it, h of x? I am going downward. So my limit as I approach 2 from the left has me going down here, which means negative infinity. Okay, let me scooch this out of the way because I don't need it anymore. My limit as I approach 2 from the right side, which means I'm coming this way, is going to be positive infinity. So h of x equals positive infinity. Horizontal asymptote is asking where this levels out. Well, in order for me to find out what my horizontal asymptote, where it levels out, I need to do the end behavior at the same exact time. So the way you do the horizontal asymptote, the end behavior, stuff like that, is you take a look at the leading term in the denominator and the numerator. So the leading term in the numerator is x squared. The leading term in the denominator isn't as obvious, but it's an easy fix. If I were to do x times x, or x times x, or x times x, I also get x squared. X squared over x squared simplifies out to regular 1. So my horizontal asymptote flattens out at regular 1, which is going to be the equation y equals 1. Which means my end behavior, as I move to the left, is going to flatten out at 1, and as I move to the right is also going to flatten out at 1. So the limit as x approaches negative infinity, as x decreases without bound, of h of x is going to be the same as the limit as x approaches positive infinity, and those both equal 1. Since I ran out of space there, I wrote it out as they all equal each other. But yeah, there you go. Kind of a complicated problem. Multiplicity never makes things fun, but we figured it out and we had a great time. Hope this helps.